Hello everyone, I'm G. Vaishali, bearing roll number 447. Today, I'm going to present a seminar on the subject switching theory and logic design. My topic is registers. There are many type of registers. Buffer register, controlled buffer register, bidirectional shift register, universal shift register, and so many. Let's go to the introduction. The basic shift register is a group of flip-flops connected in series to store and shift multiple bits of data either left or right with clock pulses. The register that shifts the bits to left is called shift left registers. The register that will shift the bits to the right is called shift right registers. Based on the data load and retrieval from the registers are classified into four types: SISO, serial in, serial out; SIPO, serial in, parallel out; PISO, parallel in, serial out; and PIPO, parallel in, parallel out. The basic register shift definition is it is a group of flip-flops that is connected to in series to store the data and shift the multiple bits from one region to another region or one state to another state with the connection of clock. Bidirectional shift register. This type of register allows shifting of data either to left or to the right. It can be implemented by using logic gate circuitry that enables the transfer of data from one stage to the next stage, to the right or the left, depending on the level of the control. As I said, the basic definition of register, the bidirectional shift register allows shifting of data either to left or right. It can be implemented using the logic gate circuitry. Uh, we we make the logic gate circuitry based on the clock input that enables the transfer of data from one stage to the next stage to the right or left, depending on the level of a control lane. Here, the left or right is the control input signal, which allows data shifting either left or right. Uh, the right or left is the control input signal. If it is low, the data in the register shifts towards left. If the control signal input is low, then the register shifts towards left. If the control input signal is high, the data in the register shifts towards right. This is the this is the circuit diagram. The four flip-flops DQ, DQ. It is a demultiplier. Every register is a demultiplier, as we know. The DQ flip-flops port and attach it to a NOR gate with two AND gates. Let's see the SISO register. A serial in, serial out shift register accepts data one bit at a time through time a single input line and output data serially. This means the SISO accepts the data in one bit at a time through a single output line, and outputs are uh, released serially. Data enters and leaves one bit at a time in serial sequence, typically made of multiple D flip-flops connected in series and synchronized by a common clock. As we discussed, the registers are uh, designed through the D flip-flops connected in series and synchronized by a common clock. The clock is common for every register. This is the circuit diagram. This is the clock. Switch 1 is on and 0 is off. Based on the clock, we give the input to the diagram. This is the clock, and each clock is connected to every flip-flop. This is also a DQ flip-flop. The serial input is serially, and output is also serial. SIPO register, serial in, parallel out. Shift register accepts data one bit at a time through a single input line and output data parallelly through multiple lines. Data input one bit at a time and outputs all stored bits in parallel PISO register. A parallel in series out shift register accepts data. We know that we see in the serial in, serial out register, the it accepts the data at a time through a single input line and outputs are serial. Here it is also accepts the data one bit at a time through a single input line and output data parallelly through multiple lines. Data is input one bit at a time and outputs are stored bits in parallel. We'll see the circuit diagram. This is the another clock. This is the another clock. This is the clock connected to 4 flip-flops. This is the parallel output. Each output, each input connected to the parallel output. This is the series input. There are 4 flip-flops. All are DQ flip-flops. We'll see the next resistor. Piezo resistor. A parallel series out. Shift resistor accepts data multiple bits at a time through multiple input lines and output data serially through a single line. Here, the reverse of the SIPO register. A parallel, the register accepts data multiple bits at a time through multiple input lines and output data serially through a single line. This is the circuit diagram, the logic gate. These are the inputs. These are the inputs given here. G4, G1, G5, G2, and these are. This is the clock 101. Here also 4 flip-flops connected in serially. This is the NOT gate shift or load connected to each flip-flop AND gate inputs and outputs. This is the serial data out. Here we will see. Serial output and shift load here. Each gate is connected to the shift load line. You can see here. This is the free in air. The inputs are connected to each gate. We can see here. Each input is connected to every gate. We'll see the next resistor. PIPO register. A parallel in, parallel out shift register accepts data multiple bits at a time through multiple input lines and output data in parallelly through multiple lines. In parallel out register, it accepts data through multiple input lines and outputs also parallelly through multiple lines. If we see SISO, SIPO, and PISO, these are the opposite. Either both are series or one parallel and one series and one parallel. Here PIPO, both are parallel input and output. The shift register accepts data multiple bits at a time through multiple input lines and output data parallelly through multiple lines. This is the logic gate. And here we can see this is free in air for every flip-flop. And clock is connected to each flip-flop. We can see here. Here one end is free in air and another end is connected to the clock in every flip-flop. This is also a DQ flip-flop. These registers are these registers are at D flip-flops multiplied or designed with D1. This is the parallel output and parallel input. This is the parallel input. Parallel. Universal shift resistor. This is the last resistor. A universal shift resistor is a n-bit resistor that supports both left and right shifting as well as parallel loading using n flip-flops and n multiplexers with shared selective lines to control the data flow. Here, the universal shift resistor is an n-bit resistor that supports both left and right shift as well as a parallel load. Universal shift resistor accepts the both left and right shift as as the bidirectional shift register, as well as parallel loading, using n flip-flops and n multiplexes. Here we use flip-flops as well as multiplexes with shade selected lines to control the data flow. It combines the features of bidirectional and unidirectional. We should remember this. It combines the features of bidirectional and unidirectional shift registers, enabling versatile data manipulation. This is also important. It enables the versatile data manipulation shift left, shift right, shift parallel load and hold. We'll see the circuit diagram. Is this circuit diagrams? There are 5 flip-flops here and attached to the another two. Here another two and here another two. There are overall 9 flip-flops are there. This is the serial input. There are 5 B1, B2, B3, Bn minus 1 and Bn. These are the parallel input bits, the serial input for left shift. Each output is connected to the one end of another flip-flop. Here we can see the output of this flip-flop connected to the first end of the uh, below flip-flop. Here also. Here the clock is clear. Clock is connected to these two flip-flops and a clear. Here also it is a parallel output data line as we see. Here also the same procedure. The output is connected to one end and this output is also connected to one end. A clock for both the flip-flops and a clear for both flip-flops. This is the parallel output bits and parallel input bits. Q1, Q2, Qn minus 1 and Qn as B1, B2, B3, Bn minus 1 and Bn. Thank you. This is the end.